Hello and welcome. Thank you for assessing this assignment. This assignment is for predicting electrical energy output of combined cycle power plant. Uh, the assignment gives us the possibility of making use of Google Auto ML, Excel sheet, or Python programming to complete this assignment. Whereas I have tried using Google Auto ML and Python programming. However, I ran into issues while I was trying to solve this assignment with Google Auto ML. There is a feedback as well for the course creators. Google Auto ML has been migrated to the Vertex AI platform, and for the people who are trying to complete this assignment with Google Auto ML, might run into issues with roles and responsibilities. You will, if you are trying to do it with Vertex AI. So, well, moving to the next slide. The agenda is to identify the machine learning approaches and the output metric for this particular assignment. Second is the feature and algorithm selection. Then we'll be going through the implementation approach. And fourth is the comparison of different algorithms. And fifth, last, is the model performance that we'll evaluate. The problem statement is in this project, we'll build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery system, steam and heat recovery steam generators to generate power. So in this slide, we are discussing the possible machine learning approaches and the output metrics. Given the nature of the task, a regression approach is needed. Classification does not suit this, so we are making use of the regression approach. Several regression algorithms can be considered for solving this problem. Linear regression, lasso regression, ridge regression, decision tree, random forest, any of these can be used. And the output matrices that can be chosen are mean squared uh, and R squared. There is MSAE as well that can be used, and there are other matrices that can be chosen. But for this project, we'll be using the mean squared error. It will be the temporary metric for evaluation, and MSA is chosen because it is widely used, easy to interpret, and places a higher penalty on large error, which is beneficial in ensuring accurate predictions. Additionally, R squared will be used as a supplementary metric to provide insights into proportion of variance explained by the model. Moving to the next slide, the features used um, and the algorithm that have been selected for the implementation. The features are temperature, ambient pressure AP, relative humidity RH, and exhaust vacuum V. And the algorithms that have been selected are linear regression, lasso regression, and ridge regression. On this slide, we see the test strategy. So I have made use of the fixed validation set strategy, and it is for so how I have done it is I have splitted the data into the training set and in the 60 and 40%, and then I have split it further. The remaining 40% I have split further into 20% validation and 20% test set. In this screenshot, you can also see that the model has been split for the lasso, ridge, and the linear implementation, and the training set has been implemented accordingly for each of the models. Moving next, this is the solution implementation using Python, and the models I have done a comparison of in the matrix. You can see a comparison of the values of the coefficients, the intercept, the mean squared error on the training set, the mean squared error on the test data, the R square on training set, R square on test, adjusted R square. So there are some more parameters that I have used in this matrix. You can see the values of the mean squared error are relatively close: 21.68, 21.7, 21.68. They are relatively very close for all the three: linear regression, lasso regression, and ridge regression. This is the screenshot for the program that has been used for creating the model and training the model. So, which is the best model if we are now comparing the linear lasso and ridge for mean squared error, the R square and adjusted R square? We see that the values are really, really close. All the three models, the linear, lasso, and ridge, perform very similarly with slight differences in their mean squared error and R squared error. Ridge is marginally better in terms of lowest mean squared error, indicating higher prediction accuracy. So there is very little difference or no difference at all in the performance of the three models. Hence, it is, yeah, but given the fact that the ridge regression is marginally better in terms of lowest mean squared error, it can be concluded that it appears to be the best for the regression method for this problem statement. So that will be the end of my presentation. Thank you.